So we are working through OpenStax statistics. This is section 3.3, and we're going to discuss two basic rules of probability. So first, we're going to discuss the multiplication rule. So we kind of have already talked about the conditional probability. So the probability of A given B can be computed by taking the probability of A and B and then dividing by the probability of B. And so you can rearrange this formula. So you could multiply both sides by the probability of B and basically rearrange this formula to get that the probability of A and B equals the probability of B times the probability of A given B. So it's just rearranging this formula. So with the multiplication rule, if you know that two events are independent, then one thing that you know is that the probability of A given B is equal to the probability of the probability of A. And an extension of this would be that this is also really part of the definition of being independent, but we just want to take a second to now really appreciate this. The probability of A and B becomes the probability of A times the probability of B. So if you know that two events are independent and you're talking about an and situation, then you just multiply the probabilities together. So it's really a shortcut that you can utilize when you are talking about independent events. It's just something to make your life easier. The other rule that we're going to talk about is the addition rule. And this is another rule that's designed to make your life just a little bit easier. So we have a rule that if you have the probability of A or B, so we've already kind of discussed this. So you add up the probability of A and B, but the intersection ends up getting counted twice, so you subtract that off. But the thing is, if you know that these are mutually exclusive events, then you know that the intersection is 0. So you can effectively then, this part of the formula just becomes 0. So the probability of A or B is going to be the probability of A just plus the probability of B. So multiplication rule is for independent events. The addition rule is for mutually exclusive events. And it's just shortcuts if you know certain qualities about the events and how they relate to one another. So let's now take a look at a couple of examples here. So Klaus is trying to choose where to go on vacation, and his choices are New Zealand or Alaska. He can only afford one vacation, and the probability that he chooses New Zealand, so the probability of A, is 0.6, and the probability that he chooses Alaska, so that's the probability of B, is 0.35. So since he can only afford one vacation, he can't take both. And so since we know that these events now are mutually exclusive, right? The intersection is 0. That would mean that we are allowed to leverage the addition rule. And so the probability that he chooses New Zealand or Alaska would be found then by just adding up the two probabilities. So that's what the addition rule says we're allowed to do if we know that the events are mutually exclusive, which we do in this case. Now, you'll notice here that the probabilities do not add up to 1. So there is a 5% chance he will decide not to go anywhere on vacation. So that's what that remaining probability is. Okay, so now let's talk about another example. So Carlos plays college soccer and he makes a goal 65% of the time that he shoots. Carlos is going to attempt 2 goals in a row in the next game. So A is going to be the event that Carlos is successful on his first attempt. So the probability of A is 0.65. And then B is going to be the event that Carlos is successful on his second attempt, which is also going to be 0.65. He tends to shoot in streaks. So pay attention to this last part. The probability that he makes the second goal, given that he made the first goal, is 0.9. Okay, so this is kind of important because now this is going to inform how we answer the rest of these questions. So we have 4 questions here. What's the probability that he makes both goals? What's the probability that he makes either the first or the second? And then are the events independent and are they mutually exclusive? So let's dive into this. So first of all, let's start with the probability that he makes both goals. So this is now where you really have to kind of pay attention to the language that was used here. So I'm going to highlight this one more time. So the probability that he makes the second goal given that he makes the first goal, so that's a conditional probability, right? And so what that means in that conditional probability language, right, is this probability of B given A. So then if I'm trying to compute the probability of B and A, well, I can use that rearranged conditional probability formula and use the probability of B given A times the probability of A. And so as you can see here, I have now backed into what is the probability of making both goals. It's 0.585. So it's really just backing into the calculation. So the second question then of what is the probability that Carlos makes either the first goal or the second goal. So that's an or, right? So we can now use that classic or formula. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Now, we already proved in part A, clearly this is not mutually exclusive because we have that this and statement, right, it's not equal to 0, it's equal to 0.585. So when you're talking about when do I get to use the addition rule, it's only when you have kind of that standard formula, and it's just kind of telling you, like, if you can show that they're mutually exclusive, then you can use this formula in a slightly different way. But now I have shown they are not mutually exclusive, so I'm just going to use the normal formula as is, and I'm just going to plug in what I know. Probability of A is 0.65, probability of B is 0.65, and the probability of A and B is 0.585. So that's going to give me 0.715 for my probability of A or B. So continuing on with the next question, so are these independent? So they're not independent. You can prove this by multiplying out just a few probabilities. So we already proved, right, that the probability of B and A is equal to 0.585, but the probability of B times the probability of A is equal to 0.423. So clearly these are not equal, so that does not work. And I should probably also just mention here, right, so don't forget that we already talked about that the probability of B given A was equal to 0.9. That is definitely not equal to the probability of A or B, right? So we probability of A and B were the same thing. Oh, my bad, I meant to write a B here. Okay. But clearly these are not going to work either. So they are not independent because we can't prove any of those conditions, so they're not independent. And we also know that these events are not mutually exclusive, right? Because we already proved that the intersection was equal to 0.585, and this needs to equal 0. So that is it for that one. So we have one last example here. So we have Felicity attends a junior college, and the probability that she enrolls in a math class is 0.2. The probability that she enrolls in a speech class is 0.65, and the probability that she enrolls in a math class given that she enrolls in a speech class is 0.25. So M will stand for math class, S will stand for speech, and M given S will be math given speech. Okay, so we're now going to go through just another handful of questions with the information that we have and just see what we can do with it. So we want to know what is the probability that Felicity enrolls in both math and speech, and we've been given a hint here that to find the probability of M and S, this is going to be calculated as the probability of M given S times the probability of S. So remember, we were just told that the probability of M given S is 0.25, and the probability of S is 0.65. So to find this probability, I just need to multiply these two probabilities together, and I will get this number here, 0.1625. So I've got the answer up there for you right here. Okay, so the next question is, what is the probability that Felicity enrolls in math or speech? Okay, so now we're using the other formula. Now, I want to point out that once again, so with like what rules can we use? We've just shown, right, that M and S is not empty. So now we're going to just have to bring everything together. So here are the three relative, or the three probabilities that we need for this. And so this just comes down to plugging in the information that we've found so far. And so in completing that calculation, I will get this number here. So now we should be able to pretty easily answer two questions. Are these two events independent? So, put another way, is the probability of M given S equal to the probability of M? For sure, this is not true. So these events are not independent. And if you check the other conditions, you will also clearly see pretty quickly that none of these conditions can be met. And then, are they mutually exclusive? So we just found, right, that the intersection is not equal to 0. So also that is no. And so that brings us to the end of this video. I'll catch you guys in the next section.